Okay, now what we're going to do is I'm going to take you guys on an adventure. And I was thinking about this. How do I want to do this? When I talk about an adventure, and will literally be an adventure. But the first thing I'm going to do is I'm going to start with a class library. And let's just call this one adventure. And if I did not mention ad hoc enough, this is definitely going to be yeah, we'll leave it that. Very much ad hoc. So if you want to throw some stuff out there, you're more than welcome to do this. Right now, .NET 6 is the long-term support. .NET 7 came out November 8th, I believe it was. And it is considered, well, they call it current. But it is, I'll show you the font in just a second. I'll show you what that exactly is. So .NET 7 is considered, well, they say standard term here, but it's also considered current. And which also means that since November 8th, .NET Core 3.1 is now nearing its end of support. And I think that was actually, if I have to look it up, December 13th. But regardless, so we're going to be at least .NET 5, but it's already out of support, so I'm not going to worry about it. So if I'm going to pick one to start a brand new code base, it really depends on what I want to talk, what I want to code. For example, if I'm just going to do a class library, and it's going to be super easy to advance that to the next .NET version, fine. .NET 6 is perfectly fine. It's going to be long-term support. If, however, I really, really need something that is in .NET 7, then that's fine to use. Just understand you'll be moving to .NET 8 starting roughly this time next year, because they plan to have .NET 8 out at the early November of 2023. So for now, we'll do a 7. And let me get this created. I will create a console application, but I'm really not worried about that. And I really want to explain my thinking on that as we go through this. There is plenty of madness to my methods, so you can enjoy the ride as I do as well. You got 7 more months of support of .NET 6. Yep. And I think, yeah, if I'm not mistaken, it was .NET Core 3.1 that ended support in December 13th. I think it was. Why is this taking so long? Because I'm doing a demo. And it decided to jump to another screen. Lovely. Okay. All right. Yes. Thank you, Paul. I really appreciate that. December 13th. I only randomly remember that because I was in a discussion recently talking about that specifically. So I promise you, I don't just have magic dates memorized for the heck of it. Okay. So first thing we want to do is when we talk about an assembly, let's do this right quick. I am going to do a build, and you'll see me going, like I said, this is ad hoc. So I'm going to be around various places. And okay, so I succeeded. And I want to cover various things that were brought up in this previous discussion with that friend of mine. And because not just, he had these maybe misunderstandings or whatever, but if he does, then other people do as well. Okay, so I simply enough created a brand new class library and I hit compile. So what do I have is I have an adventure.dll. This DLL is an assembly, meaning that I could put all kinds of classes, and we'll put all kinds of classes and objects, and we're going to build several of these things out. And when I compile this one project, this project's going to create an output file of a DLL, and that is an assembly. If I add a console application, I will have 2 DLLs. So each one being independent assemblies. Why does that matter? And why am I starting with a class library? For everything we're going to talk about, it doesn't matter how it looks. And I'm not worried about persisting data. I'm thinking of everything that's in the middle. We can say it's the business logic, but everything we're going to see here, you can put in a UI layer if you want. Now, not every class that we create, I'll still talk you out of that, but the concepts, like what a class really is and etc. So that's what we're going to talk about. That's where we're going to get started. So first thing I want to do is change this class name to adventure, because we're going to go on an adventure. Now, what cool stuff should actually tell you what I want to do. I am going to start in a different spot, and I will tell you why. Class animal. First thing we're going to do, we're going to talk about a class of animal, provided I can typificate. Okay, and to quickly go over that, not the debugging, I want to go to text editor. No, I know it's environment, and I know I clicked on the wrong thing already. Environment. I wanted to cover this right quick because I do and have presented a lot from this computer. I use Cascadia Mono is the font, and I do find things like the data tips, and I've increased that size, and I'll show you where that is in a bit. If you ever hit debug and you hover over your mouse over to some object that you're, or variable that you want to look at, and it has a little pop-up thing, that's called a data tip. And I don't remember exactly what it was, but I think environment is the everything else, the menu up above, and from the font and size of everything else in the windows, that's under environment. So, okay. So we're going to start with the first object. Now, this object is a class, and we will discuss what this really means and what does it compare to and various things. But we can start from here. Now, if anybody is brave enough to come off mute and want to help spout out some ideas, feel free. Else, this is just going to be a interesting random thought ride. So we're gonna have a class that's called animal, and I'm going to use this as a base class, not an abstract class, but a base class, and you'll see where I'm going to go from here. So I have an animal. What does every animal have? How about we say
eyes?
They have eyes. Does every animal have an eye? Sure. How about we do eye count? Will that suffice?
It could.
Okay. All right. So we're going to do get set, and then I'm going to do public string. Let's have a name. Now, and the reason I was steering you that way, because if I wanted to have, let's do it. Public struct leg. What does a leg have? Y2, oh, already hitting this up. Y2 classes in one file. I literally was just thinking about this. Why would I do that? So there really, I have three reasons. Number one is if the two or more classes have reason to be next to each other, such as an animal is going to have a leg, and you're going to see that in just a second. That's when I would say, okay, that's fine. The rule number two is if the code is really small in size. Once there's a lot of functionality, I really recommend break that into files. The main reason for tonight, which is my number three, is yes, because I'm just doing examples, and I'm going to be going back and forth up and down the file. and kind of scooting around. And if I have multiple files open, it might be easier, but it may not be. So I want to start here at the very least. And because when you see things like, and you kind of see where I'm going with this, I'm going to have multiple legs. You can kind of see already that I have also painted you into a corner. One, I want to have multiple legs. Let's make sure we call them legs. Now, the reason I wanted to do this, and yeah, okay, so this is a new guidance on some latest .NET level. I honestly don't care, but this is the suggestion going forward, is if they're nullable, denote them as nullable. But they're already nullable, so that just, anyway, they have their reasons. What's that?
They also added the ability to use a exclamation point instead of a question mark and say this is never going to be null. So that's where that came into play too.
So that's like saying, hey, well, maybe not on that specific one. How about here?
Well, you're also not setting it too.
Yeah, that's true. Setting, that'll ignore the warning.
Yeah.
Yeah, it's just, you can still have null references if you do that, but you're just saying ignore it. Tell the compiler to ignore it.
So if I did something like this, where I've got, now let's go play. Probably because I have a setter.
Yeah, well, the exclamation points on when you're setting a property that something, or accessing it, something that can be null.
Gotcha. Okay. All right.
Yeah, the default now, but not having a question is that it can't be null unless you put a question.
Right.
Okay. Well, that's supposed to. Technically, it's just a warning. It won't really force you.
Yeah.
Okay. Okay. So first thing you should notice is that legs is an array of another object called leg. Now, I went down an interesting road already. So now I have a class and now I have a struct. And so the first question, the big question that is always out there is, why the difference, and does it really matter? And this is where we're going to, and this is one of those tangents that we will go on, is when we're talking about reference types and value types. And this is where Mr. Dana gets to jump in and go, because I'm going to say a class is always a reference type. And a struct is always a, no. It's, is that true? It's always a value type. I know is always stored, if I'm not mistaken, stored on the stack and always on the heap. Now, I'm going off on a slight tangent, and so we're talking about stack, and we'll start with stack and heap. In the memory, since .NET manages the memory space, there is a section of memory that is pre-allocated. Yeah, the word always may not apply on the stack or on the class. The stack is where value types are stored. Now, not every value type. And what I mean by that is I have an integer. An integer is a value type because its size is known. Now, just with the class here, this is always a reference type, and this value type is not always stored on a stack, because this will also go with the class in the area that's on the heap. generally speaking, not valid in New York and New Jersey. Nice. Technically speaking, memory that is in the stack is quicker access. Now, this is where you can kind of argue this, because memory, if you know the address, you can jump over there. That's not necessarily the point of that. How it's stored on the stack is what makes this a little bit faster than finding things when it's on the heap. But the size of the stack is much smaller than the size of the heap. Now, how big are they? You're really not going to know. And yeah, new leg, you're going to have it on the heap. How big's the stack? How big's the heap? You're not going to know, because it varies based on how much memory you do have. It matters on the processor you have, various other things that go into that. That part doesn't matter. So if you're talking about an interview question, the stack is usually smaller. Well, it is always smaller and is generally considered faster. The heap is much larger, generally considered slower. And that's only because of the amount of stuff that is stored on the heap. Because when we get into this, and we're going to play a little bit here in just a moment, that when I'm passing a class through a method, we're going to understand what exactly is passed and values versus addresses. So now, struct versus class. I never use a struct, and it's part of it is just out of habit. I just never feel the need to use a struct. But the general guidance is if you do use a struct, use it for a very small object. And so something like, if I have public, I don't know what jumped, let's say a double, and I have length. Yeah. And I want to do this. We'll just do, yeah. Okay. Quick property. It's a small object, so a struct is fine here. Okay. Now, when you get into, there we go. I like that. Struct is a part of the language for backwards compatibility with C. It's rare to find in a program. I generally just don't use them. I know they're there and it's fine. But if you never use one, I don't think you're going to be that hurt, certainly in the .NET space. And that's where we're staying with for now. Okay. So I'm going to move this to be in a class, and let's remove that piece there. And so now I've got a class. I'm going here. I now have an array of legs, so I can have more than one. Now, notice that the instance itself, or the definition of the class, is not defining how many legs. Well, that could be up to the type that we have. And not only that, you can think of it as, well, how real world do we want to be? What if it's a dog missing a leg? Well, then it's got 3, not fully defined 4. So we don't necessarily be static on everything we do. And if you're going to do something like we're medical records of a vet type system, then it's okay to have something that's not strictly defined right there. Okay. Now, since I have an animal, let's go quickly go to public class. We're going to do a giraffe because why not? And this giraffe is an animal. Now, notice what I said there is that a giraffe is an animal, meaning that it is a derived class that is getting base information from the base class, and it will extend that. It can extend that. So what if I have public double, let's do neck length. Okay. What I'm saying is that the giraffe can have a property that's very specific to it that the animal does not have. And let's see, let's go play with that. So now let's do public class foo. Oops. And public void do something. Now let's say I've got a equals new, yeah, let's do new animal for right now. Okay. And we can tell that I've got a count of eyes, and I have an array of legs, and I have a name, horns and spots. Yep, I like that. Okay, so public, we can do public Boolean has a horn because maybe it's too young yet. And public Boolean has spots. That'll work. I don't know. I've never seen a newborn giraffe, so maybe they don't have spots yet. I have no clue. But the point is, you can see that as an animal, those properties are not here. By the way, notice this pop-up box right here. This is that data tip I was showing you that has the larger font. And you can change the font specifically for the data tip. And you're welcome that I did not use Comic Sans. So I can do that as an animal. If I do that as a giraffe, then giraffe dot has horns, neck length, and is available to us because it is a giraffe. Okay, so let's go do some things like Jeffrey. Hopefully everybody remembers that name. Some of you may not. The Toys R Us toy company had the mascot that was named Jeffrey, and actually with that spelling. And let's do a neck length, and I'm gonna, it's extremely let's just say 6.5, and that's, is that 6.5 inches, 6.5 feet. That can be determined later. I'm not worried about that. I just want to show you something. Okay, public void. Actually, we're going to return. Now we'll do a void for right now. Do work, and I'm going to take in an animal. Okay, so now I'm going to pass the animal into here. So I'm going to say do work. If I can typificate, that would be awesome. I'm using a keyboard I have stopped using some time ago. And you saw him at Macy's. Well, that's pretty cool. Somebody saying something?
I was just saying I hate that because they wanted us to pick up our stuff from the office if we were working remote. So I did yesterday, and I tried to log into my computer using my keyboard there at work. I could hardly type on it, and I hate that mouse now.
Yeah, I got so used to a Mac that I'm coming back to this, and I've already hit Windows S instead of the Command S, because I like to save files often while I'm editing. And I've already hit Windows S trying to mess with it, and I'm on the wrong keyboard. All right. So notice what I'm doing, as I have a method that is expecting a type animal, and the focus then is saying that the business logic focus is on a animal object. Okay, so a dot, sorry, name, eye count, legs, name. Okay, and in fact, let's do foo name equals that. And but what I don't have is I don't have that neck length, because it's an animal, not a giraffe. Okay, so what is interesting, and tell you what I'm going to do, let's go ahead and add a new project, because I do want to go ahead and fire this off, and we'll play a bit. and console. Now, I just saw something, .NET Core versus framework. I would, 99% of what I'm going to show you will work in both. The record, I believe, is only for .NET Core. I don't think that they ported that to framework, and I don't think they will. So let's do adventure game. Yes, and leave that off for right now. Okay. So one of the things I'm going to do now that I've got my thing here, let's add a project reference over to my business logic here, my class library, I should say, because it's more in how you use it than anything else. Okay, so if I did var adventure equals new adventure, and right there, yep, there we go, adventure dot, I don't think I really set myself up for anything, so I have, so I'll probably do, let's do foo. Foo. And dot, we're going to do something. Okay. So we're going to call this, what we're doing is we're calling into the do something guy here, right here, and I'm going to set a breakpoint. Let's see, I do want to go ahead and set this as the startup project so I can kick that off. And generally what I will do is I'll start with a bunch of class library with a bunch of classes with my logic in there before I'm worried about anything on the UI. Certainly for this demo, but for a lot of other things that I do. I'm not a web developer, so I don't generally work on that stuff there. Okay, notice that I'm working on animal, and animal doesn't have a neck length. If I wanted to do that, let's say I have the neck length here is equal to giraffe of A. Okay, so now I'm casting, and I have to use this. Now I have neck length. Now I'm casting, and this is a really funky way of doing that, but what I want to do is not have a dot neck length because will it do that for me? So I didn't think it would. Yeah. So right now it's trying to cast the whole thing here, not just A. Now, a better way to write this is A as giraffe, and now I got neck length. Okay. Now, yeah, possibly a null reference, because this is one of those things where just because you can doesn't mean you should. The focus is on the animal object here. If you're going to cast it back to a derived type, you're better off taking it in as a derived type. But I'm showing this because you can, and I want to because I want to show you what's going to happen to this object specifically. Okay, so let's run this, and I should be able to hit that breakpoint after my system decides to think whether or not it's going to work for me today. It already blue screened yesterday, so I'm hoping we're going to be fine. Okay, so as I hover over, and this is that data tip I was telling you about that has the increased font for that. Yeah, you may not have never casted, and that's okay. Knowing that it's there is different than saying you should. Don't do that. Well, the handling of the nullability. Yeah, is if it blows up as a null reference, that's the thing right there. Okay, so as the giraffe, it has that neck length set at 6.5, and we didn't set any legs. I'm not worried about it at the moment. Okay, so now as I step through this, come on. Let's do this instead. There we go. Okay, so now you can see that the name is Jeffrey and the A is the exact thing that got passed in. Okay, and as let's do this. Okay, as I cast this back, there's that neck length of 6.5. Thank you, Gary. And the reason for this is, and this is the reason I bring this up, is in the instance of this class, the instance of that giraffe that is an animal can be passed in because it is deriving from the class that is required here. Okay. But since it is a giraffe, I can cast it back to a derived type, the type that was passed in, and get the access to the state of that object. So, two things I wanted to point out. That the instance that's being passed in right here is not a copy of the instance itself. It is a copy of the address of where this is at. Remember, I have a variable that is pointing to an instance of this, and I have a new variable that is also pointed to the same instance. So two different variables, G and A, that are both pointed to the same instance of the giraffe that is an animal. So what's actually happening here is you can think of it as, regardless of what you send me, an animal or anything that derives from it, I'm going to treat it only as the type specified. This casting back to a derived type is saying that I will treat that object as a giraffe and the state is still there. So the other piece that I wanted to point out, in case you're not aware, is when you have data like this, such as the neck length, the name, the eye count, and, does it have horns and spots, things like that. This is state. It's not business. It's not, I'm sorry, it is not functionality. It is just state. It's the values of properties.
Question about the casting.
Yes.
Is it basically saying, okay, I'm going to map what I know I can map? And so like if you're trying to map an animal as a giraffe, he's saying, okay, I can cast these, but there's the potential these things that I don't know are there aren't going to work.
Yes.
Okay.
And so if I have let's just do the dog, and it is from animal, it is an animal. Okay. And what does a dog have that a giraffe doesn't? Let's just say a larger set of teeth. Molars? I don't know. Canines.
Yeah,
Canines.
canine teeth.
Canine teeth. Yeah. Okay. So let's. I was thinking teeth. That's funny. Has a canine teeth, and we know this is going to be true. So let's just do get, and it equals true. Okay. Now stop hitting the Windows button. All right. Jeffrey. Yep. Okay. So the dog is an animal and it has this property that the giraffe doesn't. If I go dog the dog does not have neck length. That only belongs to a giraffe. So already it won't compile. If you try to cast at runtime to reach something, I still don't think you can do this unless you really work out a lot of magic with the using reflection. And by then I'll take the keyboard from you and bang you over the head or something. Don't do that. You don't need to do that. If you're trying to force something into a type that it just it does not have or should not do. So A is dog, dog is an animal, and I try to cast it, and I try to get something from that, it's not going to work. Now, if I do this, and this is arbitrary, I mean, this could just be foobar, it doesn't matter. Okay. Well, foobar dot has canine teeth and legs and name because and eye count because it is an animal. So when you cast to a derived type from a base to a derived, you do run that risk. So my point with all this is just because you can doesn't mean you should. If I go to giraffe.neck length, the same object is being used. Meaning that when I have the neck length of the giraffe and I have this instance, this G is pointed to the address of that instance being passed into this method. Now this variable also holds the same address of that instance. It's treated as its base type of animal and not the derived. But if I cast it back, I can get it because it's this, I can get to the state because the object itself has not changed. It's the same object. It has not been copied and it is still the same object. Okay, so I hope that clarifies some pieces of that. Questions?
Is it worth going over the is to safely cast? In case people
Yeah,
aren't
let's do
familiar
that.
with
Let's do that. Let's do that. How about, it's not a var, it's a double because it is that. So we're going to do that equals 0. And let's do if A is giraffe. So what this is doing with the is saying, can this be casted properly? Meaning is the instance that located at that address of A, is that a derived class that is a giraffe? If so, all right, let's cast it and see what happens. When I say see what happens, it will work because it says yes, it can. You know that A is of type giraffe. So is and as pattern matching for the win. Yeah, essentially. The issue is specialization. There are occasions when one derived type may not allow some operations. This is feature virtual and abstract functions don't offer. This is why the caster are used to check for derived instances. So this is why the is exists at all, to see if you can cast. But by the time that you're working in your logic, and if I'm evaluating your code, if I'm going to do if we're going to do just review a code review, and you're taking in a base type, and then you're looking to see if you can cast it to a derived, I'm going to want to know what your thinking is on this. Why not just use a derived type, right? So what about overloading the do work method? Okay, well, let's talk about that. Let's do just that. So let's make an overload. So now I've got a giraffe here, and since I already know it's a giraffe, I don't need to do this. So now it's going to be a dot neck. Something else kicked off, sorry. Now I can look directly at that, and the object here is of type giraffe. So now this is a giraffe object. Now, which one is it going to land on? Okay. So now let's go ahead and call this. We're going to stop here at the do something, and we're going to do work. And it's going to go to the method of do work that has the overload. And I'll tell you, it's going to the one that is the, I'll see if I can say this carefully. It's going to the overload with specificity. Being that the object passed in is a derived type giraffe, this one is specific and certainly most specific, so that one wins. All right, so we click through here, and oh, by the way, it's 6.5, so the state is still there. We come out, we do not go to the method of the basic type. And let's see, to answer Dan's question, I don't think you can do that, but let's see. There you go. So now let's comment out that guy there, and let's rerun it. Okay, and let's step into this guy. So now I've got this. A is giraffe D. D is now, should highlight just D. And come on, there we go. And now it is casted A as a giraffe in one command. So there you go, Dan. Yes, you can do an is and cast at the same time.
This new like .NET 5 or 6.
Yeah, and that's definitely one of those things where I had forgotten about it, and I've never done it. So it helps. Spelling helps. Spelling certainly helps. All right. Has canine teeth. Now, yes, I realize. Let's just do Boolean has doggy teeth. This is false. There. And now we can say has doggy teeth. All right. What about this? Will this work? Now, look at what I'm doing is that I'm passing in a giraffe. Okay. This is why I wanted to keep this in one file. I'm just kind of going back and forth a little bit. So I'm going to step in, and I've passed a giraffe into this guy as an animal. As I'm looking for this, and it's going to do if this giraffe is dog, won't do it at all. Okay. So it's not just what I'm pointing out is it's a true or false. There's no null argument exception. There's no null reference exception. It just says, no, it's not possible. And it falls through. All right. Any other challenges you would like to see? Is that not creating a second object of D? So where do you see the first object of D? On line 47, this is a variable declaration. This is from this guy right here. So now notice that it's trying to see if it can do a safe cast. It's not creating a new instance of dog. It's just trying to do a cast. If it can, then this is one of those key things where I wanted to throw out at you is when you have an object type being thrown in that is, a derived is thrown in to a base type, to a method that's calling for a base type, it just says, I just want to work with the base type itself. I'm going to treat the object being passed in as this type. Now, the fact that it works is because giraffe is an animal. We have that in our declaration right here. When it gets to here, let's say giraffe, is this going to create a new instance of D? And the answer is yes. Let's just do that. It's going to create a new variable, not an instance. It's not is so now think of it as up above G has address to instance of giraffe. By the way, whoops. Let's do this. Let's do this. A and D have the address to that instance being passed in. So they're just simply different variables. This variable is pointed to this instance. This variable is also pointed to that instance, the address of that instance. The difference here is up above A, and A is always treated as an animal. D, the variable D here, is treated as a giraffe. Same instance, but how it's treated. What is being treated? The contents of the state at that memory address. We take that contents out of that memory address and it's an animal. Yes, it's also a giraffe. But over here we say, as we only want to focus in on how the state that is available to it as an animal. Does that help? You're welcome to come off mute and ask questions if you want and further discuss this. I mean, this is for you guys. Yes.
If you go to do work and you change the I count to 4, and then you come back to the do something, and right after do work, you take a look and see what I count is. Is it 4? Because they both point to the same place?
Yes. Equals G dot I count. Okay. Now, doesn't matter how I cast it, A dot I count equals, let's just say 16, just to give it a weird number. Okay. All right. We're going to step through this. Yes, 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 because the only thing being copied is the address to the instance. The instance itself is not being copied. So we step through here. Yes, A is able to be casted as a giraffe of a derived type. And here the I count from 2, now it is 16. And now the giraffe up here has 16 eyes. That's what it gets for being too close to the nuclear power plant. Just saying.
Sean,
So,
I think you wanted to change it on the D variable.
you want to look at scope in that regard too. Okay.
Well, I was just trying to point out the reference type versus the value type
Well,
and what happens when you change it in a different method.
Okay. And so it's a good point. An integer is a value type because its size is known. But because it is stored as with the reference, with the instance, we stored on the heap with the rest of the stuff of that giraffe, it is part of the referenced object. It's never copied. Okay, and let's do 8. Now, what do you think is going to happen here?
Delete 55.
Yeah, all right, we'll hold that off.
There we go.
All right, I see what you're saying. And I'll tell you what we're going to do. Let's go. Boom, boom, come back. Place your bets, place your bets. Who wants to believe that the I count is 2? Can't be 16, we commented it out, or 8? It's 8. Remember that the object being passed in was successfully casted and treated as a giraffe because it is a derived type and that was being passed. So this line was hit. Again, remember, this D variable has the address to the instance of the giraffe. We are affecting the state, meaning that I count property, of one object. Just one object. There has never been a new object of anything through the course of this execution. So I'm glad we're playing with this, and I'm glad we got some different numbers on this because it means that we want to explore this a little bit more and iron that out. So because this line was hit means that, and in fact, let's just start that over because I do want to explore that a little bit because somebody could have said, well, I wasn't sure that that line was going to hit. Perfectly valid reason. All right. Is a giraffe? Well, A is an animal, but it's also able to be casted as a giraffe. D is a new variable pointed to the same instance. Now we're going from 2 to 8. Oh, gee whiz, 100 feet long and has 2 teeth. I don't know. Oh my God.
That was the longest delay for a punchline I've ever seen.
See, now if I'm going to post this recording,
You can't post it now.
well, that or I got a lot of editing to do. That is hilarious. Oh, that's wrong. Okay. Quick question. Does this answer this question about why this is 8 when it gets to here? Does that answer it?
I think that proves the theory that they're the same object.
Good deal. And that's a big thing too, is because if you pass in, and in fact, let's do that because I think that's worth exploring. Let's do I count. Oh, stop. Wrong key on the keyboard. I count. And I'm going to put that right there. And when I call it, I'm going to say, how about 32? Okay. But, so that's going to be I count. But what I'm also going to do is, how do I want to do this and prove this out? Let's do this. 32 I count. Okay. And let's do that. Okay. So not only am I going to pass in this object, I've got a variable type of integer set in. What I'm going to do here, though, is let's do I count is equal to itself divided by 2. And then it's going to set it coming out. Okay. What I'm going to look at here is not just this guy right there, but how about bar is equal to I count. So now let's look at, before this is going to get called, we have an instance of a giraffe. We have I count set to 32. Okay. So one of the questions is going to be is what is it here? And then what is it here on 39, line 39? All right, so we're stepping through this. First thing we're going to do is take the I count that was 16 and we're going to, well, 32, right? Up here is passed in as 32. Now it's divided in half. Now it's 16. Okay, step through. Yes, it's a giraffe. So the I count is 16. All right, so we're going to come back out. And yes, Scott, absolutely. That is passed by value, not by a reference. So the I count here of the giraffe went to 16 instead of 32. But now, what is the I count of this guy? It's 32. Even though it's the same variable by spelling, it is not the same variable. So that's another point too. The value was passed in. It was altered right here, but the scope of that was internal to here. It affected a integer on the object, the state of the object that is the address to the instance of giraffe was the only thing affected. So the I count went to 16. This other variable, although the same spelling, different variable, does not have the original value of 32 because it was passed by value. It was not affected. Cool. Make sense?
Yeah.
Now,
Good. No?
go to your do work and change I count to be an out.
All right. Out means I can't do this. So let's do that. Okay. You're just going to type that. All right. Uninitialized. Nope, I don't get to do that. Come on, let's do. What do you say? Unassigned out parameter. Yeah. All right, what am I doing wrong?
You're no longer passing a value in, so it's got to be created inside the method. So
Okay.
var I count equals, or like double I count.
So var I count
Equals 32 or something. Now you do I count.
do what?
Right now, you don't need the var the first time. You just need to set it to something, so you couldn't divide it by itself.
Oh, okay, because when it's okay, I got you.
Yeah.
That's too bad. Well, I'll get around this anyway. original account. And let's say it original account. I'll even spell it differently just for the heck of it. 32. Oh, and this is because it is behind an out. Oh, nope, it's not. I was curious if you can do it with an out and then one that is not an out, because I thought usually the outs had to be at the end. Cool. All right.
I think outs at the end is a developer unwritten rule. People falling into that.
Yeah, probably.
I prefer.
Okay, so what we're looking at here is we're going to take the I count, the original. Okay, let's step into it. So the original I count was 32. You can see that on both. This I count is already 16 because I affected it by being the original 32 divided by 2. Okay. Yes, it's a giraffe. The I count, originally 2, is going to be set to 16. Meaning that the giraffe's I count is 16. This I count being an out is 16, not the original 32. Cool. Make sense?
I like Alex's suggestion.
Yeah, that's what I was going to say originally before we went to the out instead.
Mm-hmm. All right. So is it ref instead of out or in addition? It's instead of. All right. Oh, yep. This is ref. Let's run. Okay, original 32. This I count is 16. Come back in. Yes, I count from 2 to 16. Come back out. The giraffe's I count, 16. This I count, which is matching this guy up here, 16.
So what's the difference between ref and out?
I didn't have, well, let's see. So the ref must be initialized. Ooh, let's see. Well, if I do that, it's simply set at, it's not assigned, so it has to have a value up above or above it. So it's something like that. Out should be declared inside. So let's go back to this. If this is an out and this is an out.
With the reference is going to be what happens to your I count that's declared on line 35 down on line 40.
Say that again, Ben.
So if you go back to the ref on both, the difference between an out is what's going to happen to your I count on line 35 when you go to use it on 40.
Okay.
Because you're passing it in as a by value, you're passing a value type into the method. And then what happens to that value variable inside the method has its effects outside of the method.
Okay. So I count was 0. We're passing. It's still a reference to the same object.
Well, it's a reference to a value type. It's not reference to, it treats the value type variable as a reference type, not a value type.
Which also means that there's boxing.
Right.
This is boxing the value type to a reference type. I think with the out, there'd be 2 different ref addresses. With the ref, you don't need the original. Okay. Let's do then so then what you're saying is if I take that and then just divide it by itself, and then let's set this to say 60. No, let's do something a little bit more drastic so I can stay away from that guy there. So if I did that, what not to do? Yeah.
I've used this a long time ago with like a counter variable. Like I'm sure if I went back and did it now, I wouldn't follow that pattern. But I remember that was something along those lines. Like almost like counting around the like columns in a spreadsheet, filling out a spreadsheet or something like that. There was some bad pattern I followed back in my early days that using it by ref got it to work better.
So I don't want to confuse any of the new people, but are what you getting at is it's best to return a complex object instead of using the ref or the outs?
Not necessarily. And I'll show you why. If I took let's see. Let's do, what is it? Boolean dot triparse. Notice the triparse has an out Boolean. This Boolean, in fact, let's do another one. Int dot triparse. Okay. The triparse is going to return a Boolean if it was able to make a string into an integer. The result is what is out. So you have to specify and say, for example, if I said answer equals 0, and I put in 1, let's see, do answer. And I know there's a shortcut on this that's newer now, but let's do var try equals that. How about tried, just to keep it from there. Okay. So what this is saying is in fact, let's do that. Let's do this way and take that guy off there. And let's make that an S. If I'm going to take a string of 1 to an integer, okay, I'm saying that I have a holding place for the answer, okay? Whether or not it was able to be parsed is in this answer, and it says, yes, it was. So now answer is 1. It took the string to a 1, gave me out, and this type is an integer. This one is going to say false because an S is not an integer. So the answer is 0. It wasn't used. So that's where I've used outs more than anything. And when I'm passing in a parameter to hold an outgoing value. Now, this to other people's point here on about using a return value on a method or a tuple, this try method was created long before those were, well, before tuples. Okay. So how about we try a tuple? And let's do, how about int original and int I count. Okay. And it should give me a, let's do return of, and I love that because now I can use named variables. So I'm going to return the original, which is the I count, and the new I count. So, which is going to be here. So let's do it that way. Okay. Well, all right. So now I'm returning a tuple. A tuple is what I really like tuples for this kind of reason. Instead of me creating a class type to hold multiple properties like this, which I generally would do at some point when you only got 2 objects or 2 properties like this, a tuple works great. Yes, you can go really large with tuples. They make it, I don't know. I've never seen tuples causing problems with unit testing because it's just, so to the point, let's say now that do work is going to return something. I can have var answer, because I deleted up above, and now answer dot I count and the original. Yeah, it's still around. It is there for backwards compatibility. To remove a try parse would break a ton of code. It's no different than returning a complex object. It's in the way I see it is it's less code, and I don't have a class object that is floating around.
That was back more for the ref versus the tuples that we got onto. Sorry, took a minute to type. I would not say at all that tuples would break single responsibility, because if there's multiple things, especially like what you and I talked about the other day, where it's like all a bunch of private methods and everything.
Yeah, and where a tuple has the same scope as the method returning it, if I had a class, then I could have a different access modifier on the class. So, but I do like tuples. So I'll show that again. So you can get access to, in previous, if I just simply did this and I'm returning to, integers like this still works. The difference though is that it's item 1 and item 2, and you have to know the order that they're being used, not even here, but here. And that has been a problem where this will not solve your problem entirely, but using a named tuple, named property, named parameter, is a property of the tuple, you can help cut down the possible error as what if these two were swapped positions. And all this thing knew is item 1 and item 2. by using something like, and going back to where I was at. So orig for the original, and let's just call it current icount, whatever. So, and now I can have my named original and current. Okay, any questions on this?
Is there going to be a test over this at the end?
Absolutely. It just won't be my meat. Okay. So we played with tuples, played with referencing objects. I think I've more than drilled it home that everything we've been playing with is passing around the address to that instance of that object and not a copy of the object. But there were multiple variables holding that same address. And since it was the same instance of that object, a change of state will go around and cause problems, or could. But wait, there's more. Okay. So I have delved a far longer than I was planning to on this stuff, but that is 100% okay because this is exactly what I wanted to do. But we've got a lot more to go. So somebody's going to ask the question. You mentioned records. So what about a record? All right. When should you use a class? When should you use a record? Right now, everything about these classes here, the class itself is immutable. I'm sorry, is mutable. It is mutable. It is where it can be destroyed, it can be changed. And we saw that with the iCount, for example. The state can change. What if we want to have something, and let me go ahead and get rid of this because we weren't using it. How about we have a public record? And I'm going to do this example because I think this kind of fits pretty well as to when you might use a record. If you're going to have an object that has basic properties and you're okay if they are mutable, that they can change, use a class. But if you say, I want the state that is there at the instance of the creation of that instance to not ever be able to change, you'll make it immutable, then a record is available. And yes, this is available at C# 9, I believe it was, that they came out with records, 9 or 10. I still think it was 9. Let's do time entry. Okay. And I'm going to have a date time called event time. And how about a string, and we'll call it a message or whatever. Okay. So I have a type of object. I'm just trying to stay away from class because can a record be a class or struct? It is a third type. So it's not, can a record be a class or a struct? A record is literally a third type. The difference is that when you create a new instance of this time entry, since it's a record, when you supply this stuff right here, the values cannot be changed of that instance.
By the way, but a record can be declared with class or struct. So it's when you declare a record, yeah. So it can be in struct and class. By default, it's class.
Okay, I will honestly say this is new on me. I have never seen this combination.
It's
Nor-
I think it's recent. Maybe it's C# 11.
okay. All right. Well, that is definitely new on me. I did not know that you could do a record struct or record class like that.
Yeah. So by default, at first it was only class without this class name, but then they added struct. I think it's the last version of C#.
Okay. Yeah, I learned something new as well. So what if, let's do R1 equals new time entry. And let's do date time dot UTC now. And creating new giraffe. Okay. All right, I'm gonna play.
And actually, records not necessarily should be unmutable. They can be mutable too, I think.
If they're able to be mutable, then that is again a new one. Oh, okay. Yes, I have heard about that. Yes, they can be mutable. That is like if you do some work to make that happen, they're immutable by default.
Yeah, because they don't need to have properties. Because if in declaration, if you use parameters, by default it will be properties.
Okay.
In this case, it will be unmutable. But if you use property, it will be mutable.
I'm playing a little bit right now because I want to see if that allows a const to be removed. Is there an equivalent for record in C#? You guys have got me on that one. I do not know. And this, actually, it's going to be time entry that, and then this will be T. Huh.
Yeah, I hadn't seen how you declared time entry before with the records. I've seen record used as basically instead of like class on line 74. So you can set it up with all the properties and everything as well.
Right. And in fact, I'm going to touch on record for just a little bit, but I'm far from an expert on record. And there's still some more stuff that I wanted to show you. Yes, if you want, when you say never change properties, when you want the properties to not change values, as in change state, essentially like a read-only instance of a class, yes. To Jay, to your point there, yes, they can be mutable. My understanding is there's some workaround that you have to do to make that happen. They are immutable by default, which is also goes to the other point I made earlier, is that my understanding is with entity framework, because if you think how I'm using a record right here, I'm capturing data, but I don't want it to change, much like what I would do for a time entry, is with entity framework, you do not have to use it as a record. And the reason why is because it already has, because it was built in before records were there, the ability of change tracking. And it would track the changes on each of the properties of that DB set. I believe it's on the DB set. And this, so a record could be used with dapper.net ORM if you wanted to use that, because they do not have change tracking. My point on this is, since I am inside of a class library, and if I want to keep some things in memory, and say I'm looping through and I'm going to create a new time entry based on certain events through business logic, and I'm keeping the records in memory, then they are immutable while they're there. And I am outside of the discussion of how they are persisted outside of the assembly. So, yeah, and Robert, you may be right. I do not know. Go ahead, Ben.
Yeah, the big difference that I know between a record and a class is that a class is stored by reference. So like all of it's like the quality of a class is the reference the same between these two variables? Like, are they pointing to the same actual instance of the object? With a record, the equality is on the values of all the properties.
Yeah. I wanted to try if a record as a struct. I don't know if you caught what I was doing with this method.
Mm-hmm.
If I'm using a generic and I'm able to constrain it to be a type of record, the time entry, and new, meaning a new instance of it, I was curious of how that was going to be handled. And in fact, I don't know if you can do, I guess not, as a type of record, because that's not even an option. But you kind of get where I was going with that is, and it may still be okay with this being the currently being defined as a struct. It's not not a valid constraint, because the constraint has to be a non-sealed class or an interface, a non-sealed class or type parameter. Okay.
I mean, you want to do like an anonymous record?
Ooh, an anonymous record?
I mean, that new down there, you've got that new, so you've got that.
Yeah. So what are you saying?
No, I've never tried that. I was just asking if that's what you were, you're trying to do. You're trying to build that on the fly.
Mm-hmm.
It just, I mean, to me though, it's, if you're going to make it mutable, that confuses people, because the person that comes behind you is going to see record, and record implies immutability. And if you go and make it mutable, you're just like making life difficult on the poor guy that comes behind you and like has to fix your code.
Yeah. And I'm going to try to remember the syntax of this is, because again, I just don't work with them enough.
Robert, I don't think it's possible to make a record mutable.
Yeah, I've never tried it. I don't know why.
No,
I don't know why. Who would ever want to do that? Because I mean,
I don't think you can, because that's the purpose of a record, is so that you can compare the two and focus only on their value equalities and not run into the problems with a class of the reference equality.
No, I have this MSDN up on it, and you can create records with mutable properties and fields by having it be get set instead of get init, is what they're saying.
It just seems crazy to me.
Yeah.
Yeah, go ahead, Jay. Oh, I see. Yeah. Yeah, and I'm not fully defining these out too, because I'm using these as, these are really these are more of the parameters of the constructor. You can do this, and let's say public string extra info get init, and now that is also immutable because of that.
Mhm.
So now if I go to get rid of that guy for there, and R1 is not setting it, and
Right, but once it's initialized, I don't think it can mutate after that.
extra info equals blah.
Yeah, not the way that it was set up there. If you set it up like you do the giraffe class on line 17 with the enumerated properties on different lines with getters and setters, then it becomes
Right.
a
He'd have to
mutable.
put a,
Yeah, so-
yeah, he'd have to put a setter on there in order to change
Right.
any one of those
yeah,
properties.
then that then turns it into a mutable record.
Okay, so yeah, so basically you can have two types of records. You can have a mutable record and an immutable record.
Mhm.
Okay. We've used them a couple of times on the current project I'm on, and they were just absolutely perfect for what we needed them. And but it's been a few months, and you know, it's one of those, if you don't use it a lot, you tend to
Right.
forget what you do with it.
Yeah, and I'm in that same boat now, trying to remember how to do this, because right is once it's here, let's do this. I mean, that'd be simple enough. No, is date time dot UTC now. So extra info right here is not available to be set because it is set with the init, but it will have the event time as set to this and cannot be changed because of that. Now, also that's kind of saying, well, I've got a private set. So there's similarities. Did I not? Oh, I see. Yep, equals. Let's try that. There you go. Thank you. You're right. So that, which is a good point too, because this format of initializing this is outside of it. So this is proving that the init is restricting the setting of new information.
So
So-
Sean, how
Yeah.
do you get access to the parameter you passed as, what was that message?
Yeah,
Does that
message
show up
right
as a
here.
property on the object?
Yes, it is. R1 dot message.
Okay.
And notice
what I
the
thought.
init on it. Yep. Yeah, it's a good point. Event time, get init, extra info right there, get init. Cool. All right.
All right, this is all advanced stuff. I got something basic question. If I do public string name and I don't put the getter setter behind there, I think the compiler will accept that, won't it? And then what is it?
Yes.
What's the fallout from that? What am I doing if you don't
Okay.
put that on there? Does that cause a problem?
All right. So what we're saying is, so first off, a get and a set are functions. Those are methods. This is saying that since it has no getter and setter, that there are no special methods, right, that you can do there. And it's simply saying that whatever address is holding name, that it'll just be overwritten on a set. So if I go animal name, which I did right here, it's not using a setter. It's saying grab the, make a new address, and I'll explain why here in a second. Find a new address in memory, put Jeffrey in there, put that address right there. So essentially name is a field
Yeah, it's like an
versus
variable.
a
Yeah,
property. It is still a property, but it's called a field versus a straight up property that has a get and a set. So should you use one or another?
Doesn't the compiler basically convert the properties into the standard, like a field, underlying field with the property?
Yes. Yes. It will for properties
Right.
that have a getter and a setter. There
So
does
the second example would just not use the underlying field, be exposing it.
right. I don't, because it doesn't need to.
there was some, it's been a while. I haven't touched Entity Framework in like a couple of years now. There was something about that in Entity Framework too, that properties, there was an advantage to using properties over fields, but I don't remember what it was off the top of my head. I'd have to Google it.
Well, the biggest gain is something like, let's see if I can get the syntax correctly. Return blah plus plus I count. I think it is. It is. I'm trying to remember what. Oh no, I'm sorry. I know what it is. Value. And if I can remember the dang syntax. So a get is a method. You can override its basic method with something like this. And the
Value
syntax.
is only on set.
What's that?
Value is only available on set.
Oh, I really thought value is available on because it's got a backing field.
So we can't.
Because it can refer to the value that it's getting ready to return.
I think you have to create that. Like if you created a private
Yeah,
field called value right now, it would work.
Let's do let's do like that. We'll even give it a that for one thing, I'm trying to return a string.
I think value used for set, not for get.
Oh, the value is only for, you're saying is only for set?
Right. That's what's
Yep.
passed in on your set.
Get no, let's see, is it semicolon? I forget. Return. I really think it's a 10 plus the backing field there. And then set. Yeah. There. Okay. Thanks, compiler. Oh, I remember. If you do one, you got to do both.
Yeah. You don't need the curly.
You don't need the semicolon there between them. Yeah. So underscore account equals value. Yep.
Go. And then, it should
And then
have
one more curly
Yeah,
brace.
you're missing one.
This is the danger of using all the shortcuts that we have now, is you forget all.
Yeah. Yeah.
Yeah, prop.
Tab. It's tab.
Yeah, tab. Type. Tab.
Oh, heck
Well, you
yeah.
do
Crap, I only hit tab once. Crap, I didn't.
fat
tab.
arrow 2 now instead of the curly braces around the return 10 plus I count.
Oh, yeah. So, yeah, I haven't. Oh my gosh, it's been a long time. Why would you do
Anytime
this?
there's a curly brace, I always hit enter and bring them down and indent. And
I hit Control KD and let ReSharper format it for me.
there you go.
There you go. Or better yet, you turn ReSharper on to format on save.
Oh my God, you're a get I don't even know what that would call you'd call you. Just like you could upset get changes really fast. Of course we're lazy. That's why we
I
make this
don't know
stuff.
if it's so much lazy as it is
Efficient.
throwing caution to the wind. Because it's like getting stuck in that eternal loop with ReSharper. Well, you should format it this way. Okay. Well, no, you ought to format it back the way you had it. Oh, thank you.
Yeah.
Here, switch this to a link statement instead.
Yeah.
Oh my gosh, yeah.
And then it pukes all over the link statement it just generated.
There was a plugin for Visual Studio 2019 that added Clippy to your thing, and I really wish they hooked that up to ReSharper. So Clippy would pop up with, "Oh, I see you're writing a for each loop. Would you like to help converting that to a link statement?"
I think these days Clippy would be backed by ChatGPT.
Yeah, that's right.
That's why I write a for each and then, control period on it. And ReSharper says, oh, here, you want to make this link? Yeah.
I will tell you that there are times when I'm like, okay, I want to see what your suggestion is, and I'll take it, and then I reverse it, and I take, and I go back and forth so I can learn the differences. There have been times when I'm like, I don't like your new way. It's harder to read.
Well, yes.
Mhm.
Or it's
So-
like, hey, why don't you use this instead? Okay, do that. Oh, you have to use C# 9.0 or greater to use that. I'm telling you to use the latest.
Right.
And then the CS proj file still specifies 7.3. Like, what's going on here?
Exactly. All right. I have
I'm
one
using VS
more.
2019. Come on. And
I got one more way or one more thing that I want to demo. And let's do a new class and I'll just call it Safari. Now let me go see, did I use? I did right there. I'm going to hijack that guy. Okay. So we're there. I can get rid of that for now. Let's go here and internal versus, okay. All right. So I have an adventure. And so I'm going to pop my back. Okay. We're going to go on an adventure. And one of the things that an adventure has is we have a scout. Okay. If I can typificate. All right. If I do something like public string name, and we're going to do get set. Yes, I like that. Good. And let's fix that up. Okay. So the scout has a name, but yeah, the real way we do stuff. Heck yeah. Control C. And at no point will you see Stack Overflow on this demo. Okay.
On the other monitor.
Shh. Shh. As I hide off to go get it and come back. All right. So a scout is going to go on an adventure. Okay. Now, for a scout to go on an adventure, the scout has not only a name, but it needs something else. What else would that be when it's going to go on an adventure? How about we do something like
Destination.
well, I was thinking something like I'm sorry, let's do an interface called in fact, I'm gonna leave off the light source. And this light source, let's just say it's going to have, yeah, I like that. Name, but let's go with light name because I'm confusing it with the other name. So we'll just go light name. And because of the scout's name right there. Now I have a public light source. And light source, no. I only do that in production. Now I have a light source, and I know the blasphemy, leaving the I off. Okay, the reason, and this is thank you, Scott. It will. The reason for the I was really to help years past when the tools were not as helpful as they are these last, I don't know, over a decade. So the I helped us understand that what we're talking about in code elsewhere is an interface just by a naming convention. It is not needed. Now, if I have a light source, and let's say I have a public class, and we're going to have a torch is a light source.
Now, is that a
And-
flaming torch or a British torch?
Oh, this is actually a good point, and I already thought of that. Public class flame is also a light source. Now, could you argue and make it one or the thing, make it something else? That's fine. You can do it whatever. If you want the English version, yes. It's not just UK. I think it was the old English version is a torch is a flashlight. A flashlight is called a torch.
Right.
Yep.
That's what the Brits call it.
Yep. Versus class, and I don't know why. Wow. About flashlight is a light source. Okay. Now, one of the things this thing is arguing with me about is because I have not implemented the requirement. An interface. We always hear that an interface is a contract. It's like a blueprint. What does that really mean? Okay, this is what it means. First off, as a contract, no, actually, I'm going to step back. As a blueprint, we are saying that any object that inherits and implements this interface has to build the certain pieces of it. Okay, so things like it has to have this class has to have a public string light name. Okay.
Put one more on your light source.
What do you want?
Switch.
As what type? Boolean?
Yes,
So it'd be like has switch.
sure.
Okay.
Because this helps with part of the defining of how interfaces are implemented.
Public Boolean has switch. Okay. Now, as a blueprint, this class object is being built to adhere to what is defined as this blueprint. If we think of a blueprint of a house, it says, here's what it's going to have. It's going to have a sink. It's going to have a bath. It's going to have a coat closet. It's going to have a living room, blah, blah, blah. Now, we have to implement that so that we can do that for our light sources. Why are you still arguing? Ah, that's why, because I copied and pasted the wrong thing. Wrong Stack Overflow. Let's do that right there. All right. Okay. Now, as far as a blueprint, now we're creating different types of houses based on a blueprint. So we're building different classes based on a different light source. Okay. Now, these are properties, but I want to add something else. Now, this is going to be, let's see, do I want to do it here? Yeah, let's do that. Use. I am going to have, in fact, I don't need to do it there because it is the interface that I'm putting this in. So we're going to put this here. And now this torch has to have this guy right here. And let's say it's going to Now using torch. Now I could do it as a string. In fact, maybe we ought to do that. Let's do that. So as a string, it's going to return a string, and what this is going to return is return now using torch, and I hate the doubles that it keeps doing. Okay. And string. Okay. Control KD. Now I need these other guys to implement that. So I am not only implementing properties, but I'm also implementing a method. Oh, yeah, go. Okay, so now using flame, now using flashlight. Okay, so now that's the part is where an interface is like a blueprint. It's defining the what needs to be constructed. Now, if I go and I say, yes, a scout can have, oh, wait, it may not have a light source. Maybe the scout starts out with on its journey on the adventure, and in fact, it doesn't have a light source yet. So then what we could do is make that changeable, right? So now we're going to do this. Let's go public void go on adventure. And when we go on an adventure, we're going to have var scout equals new scout. Okay. Now the scout dot name equals George, just to pick a name, and a scout dot light source equals new. How about we do torch? Okay. Now, when I go to that light source and I say use that light source, it will return a string var, let's just say result. Like that guy right there. Okay. And then I'll flip things over and we'll step through this in just a moment. Now I can use that result right there, right? So I can use this light source, but I'm going to do something a little different first. I'm going to clean that up a little bit. How about var torch equals new torch, and then I'm going to set the light source equal to torch. Now, why did I just do that? Var flashlight equals new flashlight. Because scout dot light source equals flashlight. Yay, great. And now I can do this again. And then it spits that out. Then what I can do is the scout. I'm completely misspelling that. Scout. Good Lord. Thank you. All right. Scout dot light source equals torch. The reason I changed this here is because I only want one instance of a torch. I'm not going to recreate a new instance of a torch each time I want to give our scout something as a light source. So I can use this, and he's got a light source. Well, now he's got a flashlight, and now he goes back to a torch. So I'm just swapping between instances of objects. I'm not recreating new every single time. Thank you, Dan. You're absolutely right. Scout can't count. Okay. Now, let's say I have, this is going on an adventure, and we're going to have a, let's do private void. What would be a good one? Show light source, and I'm going to take in a light source like that. Okay. And I can say light source dot use right there. And let's do that same thing. We can do var result equals. Good Lord. Okay. And then, yeah, I can do a console write line from here and say result. Okay. What I can do, so what I'm is the scout light source. This is being set. So a new instance of this torch is being provided here for the light source of the scout. Okay. And now we're saying, all right, now I want you to use it. Now go switch over to a flashlight and use it. Okay. What I could do as well is say show light source. And let's do torch. And then we could do something like flashlight. Okay. And what was my other one? The flame. So a new flame. Notice that I didn't create it. I am creating a new instance here, but I don't have one available to use by this scout. So the purpose of this is not to create, well, good code for production, but instead to show this, to demonstrate this purpose. I'm now using a method that says, send me a light source. It happens to be an interface. It doesn't care what class implements that interface. It just says, I'm going to use anything you give me that the compiler says, yep, this will work, and it will send it in and use it. Now, yeah, you probably should put in some defensive coding and go, yes, but what if it's null? But we're going to forgo that for the moment. This is the contract part. The contract of an interface right here says that a method or class that is referring to and leaning on as a dependency of an interface or an abstract class, just like any other class, you can pass that type or a derived type of it. Okay. So that's the contract part of a interface, is you send in an instance, however it implemented that interface, and we'll use it. Now, notice too that if I go to, say, torch and I add, well, if if I decide to actually post this anywhere, it will be on usergroup.tv that I put in chat. And let's do this as get set. Okay. So the torch has an extra property. So it's, it's implementing the required pieces of the interface, but also has additional pieces. The show light source method here says, I'm only caring about the stuff that absolutely implement this interface light source. If you've added something else, don't care, it can't get to it. And remember that, yeah, if I changed it to it, if I recast it as a derived type, could I get to it? Yes. Don't. Because then you're not coding to an abstraction, you're coding to something more concrete. Don't do that. code to the abstraction. This abstraction is that interface that says, as part of that contract, I can see the stuff that I know are there, the has switch, the light name, and let's see what the use method that is available, that extra, if we go back to the torch, extra stuff right here, it's not there. The light source cannot see it. It's outside of the blueprint part, that contract part of that interface. So this is where coding to an abstraction is preferred. So it doesn't matter what light source you pass it in as a derived implementation of it. It says, yeah, I can call a method that's available, and I can use the properties that are available. Anything that is defined by that interface. Now, what about a abstract class? Now, it's a class, and it has to have a body. Methods on here have to have a body, such as return, replace me, something like that. Okay. Now the method has to have a body. The interface says, oh, it's just kind of a definition that is waiting for something that is deriving it, that is implementing it to provide the actual guts of that implementation. An abstract class says, I'm going to define a method as base behavior. Okay, since this is functionality, it is behavior, and it has a base behavior because it's an abstract class. Now, as contract, I can send in a torch, a flashlight, new flame into here, and there. Yeah, they have to all be public, which I don't know why it didn't complain on the others, but we'll do that. Okay, probably because I'm just using it outside. All right, so now it says the behavior of use depends on the actual instance being passed in, the torch, the flashlight, or a new flame. Now, I'm showing you multiple things at once here. One is the use of an interface that is just the definition. An abstract class is the methods have base behavior, but with an abstract class, you cannot do show light source, new light source, because it's an abstract class. You cannot create an instance of it. Just like an interface, you cannot create an instance of an interface. So why would you use an abstract class over an interface? Because I can specify base behavior. Now, what if I don't know if I got time to go into too much on this because I'm running like really late already. Now that I finally see the clock. So now with an interface and a base behavior, yes, you can also have an abstract method. You're absolutely right. You can have an abstract method. Let me think about where I want to go with all this. Certainly in the time I've got.
By the way,
What?
in interfaces, you can now have.
Oh, I was hoping you weren't going to go there. I know. So in chat, the reason, and I'm not going to talk about it because actually I don't like it. Yes, interfaces can have a default behavior. Oh, I hate that. an interface that has a default behavior to me should just be an abstract class. However, in the chat, I posted a link to a video where a friend of mine did a talk for the user group doing nothing but, as in C#8, interfaces and the change on default behavior. That just blows my mind. And so that's, and I knew somebody was going to bring that up. And so I had already had that link pulled up aside. And I was afraid you're going to go there because I'm like, oh, there's no way I'm going to explain that default behavior in an interface. I just don't like that. Not liking that. Okay. First off, Scout. Scout is named George. Yes, I would actually put this into the constructor so you cannot change his name, but we're going to go with this for right now because that's not what I want to showcase. What I am showing you is that he has a light source. He's able to change light sources. Okay, he is able to change from one instance of a light source to another. What design pattern is that called? Any guesses?
Is it a facade?
Is not a facade. This is called the strategy design pattern.
Oh,
The strategy design pattern says that when you are coding to an interface or a abstract class, so basically when you're coding to an abstraction, and you are able to swap out the behavior. So now I'm using a torch versus a flashlight versus a new flame. And this guy right here doesn't care. It's just going to use it regardless. And I can, this thing right here does not care what the actual implementation is of these pieces. It just says, I know I can call that method. It's going to do something. But this calling class right here, and the calling method here, doesn't care. That is the strategy design pattern. And I will tell you, years and years and years ago, I was at Tulsa Tech Fest. I was sitting in a class, one of the sessions there, and I had learned that, yes, an interface, like I could have a Scout, and then I could have an interface called iScout, and then Scout implements iScout. But that made no sense to me. It just seemed more like a one-to-one. If I have a class with a interface, that doesn't make sense to me. When he demonstrated how you're coding to the abstraction there, and you're able to swap out the concrete pieces here, that it's a strategy design pattern. And in fact, he didn't use he mentioned the abstract class, but he just had it as an interface. And it worked. Now, in his example, it's like, hey, I've got a dog, but what kind of dog? I got German Shepherds, I got a Chihuahua, maybe I have a stuffed animal dog, right? And well, each of them, there's different types of barking behavior, a loud bark, a squeaky bark, or no bark at all. And then you're able to create these pieces together and swap them in and out, even at runtime. And that's coding to that abstraction using that strategy design pattern. Immediately, the whole purpose of an interface just clicked for me. It just did not make sense to me until then. And because everything I had seen is like, well, if I have Scout, well, then I can have an iScout, and yay. But having an interface or abstract class, and I have multiple classes that implement it, and so I can change behavior that is different from others, that just made so much more sense to me. All right.
Hey, Sean.
So, yeah.
So one of the things that was interesting to me is if I have class A that implements an interface, when I set up class B to inherit from class A, my class B does not have to include all the things from that interface. I would have thought
Correct.
it would have.
Correct. No. So let's quickly discuss that. Okay, so I should be able to do now the Safari, and I know I'm running late. I do apologize. Let's do that though. If I have torch, and then I have public clash special torch that extends, I actually prefer Java's word on this. C# uses a colon. Java actually uses the word extends. Because when I have special torch and I say, all right, public string, now screw it, I'm running out of time, void do something here, and let's declare about, oh yeah, okay. How cool is that? All right. So special torch extends torch. That does mean, because torch is a light source, that means special torch is also a light source.
But you change your light source to an abstract
But-
class, not an interface. But anyway.
No, that doesn't matter. The only difference here is that use has base behavior. Okay, so you want this as an interface, and now it's actually going to use that default behavior.
Yeah, I'm sorry. You got to take public off all those and that sort of stuff.
All right. What else?
Well, what I'm just saying is that when you implement it and then you inherit from something you implemented from, it was amazing to me that you didn't have to actually adhere to the contract for the interface.
Your base class is adhering to the contract for you. You get everything that
Exactly.
it has,
Okay.
which is why he was talking about extends, because it's extending whatever that base class has.
Exactly. So the extra stuff, because it's a torch, has switch, light name, and so the special torch has this do something method. And so now as a new special torch here, I can say do something, and there it is. But so is everything else about a torch. Extra stuff. Remember that the implementation is here. This is extending this type. So it's bolting on. Now, if I say, let's do this, and I say show light source, and I want to pass in ST, it works, because special torch is still a type of light source. And I'll send this code to whoever wants it, as if you'd want this code. It's that bad. So now, when I have this show light source and I have this special torch going into it, I cannot see those things actually about the special torch. I can only see things that are in the contract. The contract says there will be a has switch, a light name, and a use method. Andrew, I hope you don't define everything as public. I know. Good. So, Scott, does that help?
Yeah, the other day as I was thinking that through, that's what I came up with was what, so torch actually fulfills the contract. And so then it's done and it doesn't have to be fulfilled later on when it gets inherited.
Right. Now, but
It
what,
just was surprising to me.
okay, but what if I say public string use, and I say return now using special torch, right? Wait a minute. This use is hiding this use. Okay, remember, special torch extends torch. I have this method that is it's not even overwriting.
Yeah, but that's the same thing as creating the same variable name in your method, which is local to that method. And when you leave that method, it goes back to what it was before. I mean, that
No,
makes sense to me.
no, this is a method, not a property.
Well, I know, but
So,
I'm just saying it kind of works to me. In my mind, it works the same way.
well, if you use special torch and you want to use this behavior, because we're talking about inside of a method, it's going to use this use method right here. But the problem is this one is hiding this one. So there's two ways to do this. And you can do, and I forget which side, I think it's on this side, you could do a new and say, yeah, this is a new method intentionally hiding this one. Meaning that if I have a special torch and I create an instance of it and I go to use, I cannot reach the behavior of the base class it came from, that it derived from. What I would prefer to do is mark it as virtual. And it's going to say, oh, wait, you're hiding it. And I'm going to say override. Now, why would I want to mark this as virtual? If you use something like a mocking library, like MOQ for testing, because what if this actually reaches out to a database and I need to test this, but I don't want to go to a database. I want to play pretend. I want to pray, hey, we're going to call this thing, but don't actually go to a database. The MOQ library will actually override that method that's being in the setup as long as it's set up as virtual. So now it's overriding that behavior with this behavior. Not just hiding it, it's overriding that behavior. Now, I will tell you, Scott, to help you out, you might use virtual once, you'll use it a few times a year if you're using a mocking library, or if you really need to have this method really hide this one and override its functionality. Other than that, you're really not going to use it often, but you will use it often enough to know it's there. Add that to your list to get your hands on this, step through it and see what you can do and what you really, what's actually happening here. Okay, so let's see if this will actually run. And Alex, I hope that answered your question. You're asking about override. Okay, so with the mocking library that I use, it'll actually argue that and say that you have to have the stuff that I want to declare as so that the library itself can override the behavior. I have to go back and mark them as virtual. So do you know differently? Because I mean, that's been my experience, certainly with the MOQ library. Okay. Show light source, we're going here. Now, if I can get down to the proper screen, Now the show light source is the one that actually printed out. So now using torch, flashlight, flame, special torch. Okay. So now if I go to, and if it's a sealed class, it cannot be written unless it's virtual. So, all right, Dan, since you brought it up, and I have reason for asking this, is a string, well, a Boolean, we know its size. We know that it's size in memory, how much, bits and bytes, right? That the value types actually take up. Is a string a reference type? Or is that a value type? Remember, a value type, we know it's documented the size in memory that it takes. A string is a reference type. It's also immutable, meaning that once I say, in fact, let's do this in odd place in the file here. If I have a var, if I have string foo equals a, and then I say foo add to it b, now I have two pieces in memory. So in some location, one, there's an a. Over here, in this other location, there's AB. And every time a string with concatenation, it goes to a new spot in memory. The current spot in memory is never touched. Now, with the garbage collector, it flags it as being available for something else later because that memory address is no longer being used. But now foo with AB now resides at some other place in memory to hold that value, because it does not know until the time of the operation. It is on the heap for one, and it's a reference type. Now, the other thing about a string is they are sealed. So can you go to a string, which happens to also be a partial class, and override some of this behavior? As to your point, I don't know. So let's make a public sealed class called Dan, and let's have a public full name like such. Now, public string get full name, and it's just going to return full name. Now let's do var Dan equals new Dan. Wait, you can do that. You can create a new instance of it. So how about public class Robert extends Dan? Nope. So because it's sealed, you cannot derive from it, which also means you cannot make your own string classes. You can only you can instantiate a new string. You cannot extend a string. Okay, so we know that. And now I want to you can't override it. You can't override it because you can't extend it. Does that make sense? You cannot override a method in a sealed class because you cannot extend it. Dana, if you're still on, do you agree with that? I believe you cannot extend a method in a sealed class because you, well, because cannot
You
override.
just showed that you can't extend it, so. That
I'm sorry,
answer,
what?
you just showed that you can't extend a sealed class, so
Right.
that answered my question.
Yeah.
I feel like there's somewhere where virtual comes into play and has to be there for you to be able to override it, though. I don't know if it's necessarily sealed, but
It's abstract. It's used in abstract classes, isn't it, for the methods?
maybe.
Think about what you just said. Can you use an abstract class for a method?
No, he's talking about if you use abstract classes for the methods, then you have to mark them virtual for them to be overridden, is what he's saying. I don't know. I don't remember. I just remember running into that somewhere.
And
Like if you're creating a class that you're creating a library that's going to be in a NuGet package for people to use, and you only want them to be able to override certain parts of your classes, there's got to be a way to lock that so they cannot override others. But
right now, let's do this. Public static. I'm just making stuff, trying to explore here. If I did this, do work, this string,
class needs to be static.
yeah, I thought you could do that though, but yeah, okay. Public string and then arm1, whatever. And we'll do that. So you can use if that's what you mean, you could, yeah, they don't really extend the class. We know that. And I love extension methods. Of course, you can tell how long it's been since I've written one. You can use them as a type in here. I could, of course, use a string as a return type. And then return new string. I could do that too. You know, what's really weird though, is this new string right here. And I'll have to explore this because I have not just now thought of it. There's really no difference in that because that is a string. Oh, I'm outside of a thing. Let's do public static void blah. I do this like here, and I could go a dot 2 character array. I mean, it's a string, so I have everything else available to a string. Just as I can go 1, 2, 3, and I have, it knows that it starts with it as an int, and I can go to string and do whatever.
Yeah, that constructor would be more helpful if you're using it as a parameter as opposed to a magic string.
Right, right. All right, so let's go back on this right quick because I know we're like really running out of time. Actually, way over time. I'm surprised this many people actually stuck with me. I think they left.
We're diehards.
Yeah. Andrew, you're playing a game. I know you are.
No, actually, I'm not.
We're waiting for the cocktails at the end.
Oh yeah.
At the end, I started the night with one.
Yeah, I haven't gotten mine yet. Okay. I probably should have started drinking because my code would have been better. Okay, so we have explored user group.tv. Now, John, that's an if I decide to post this. This is my whole disclaimer on this whole time has been this is ad hoc. We're playing, we're learning. This is not necessarily some official type talk per se. Is we're just learning and playing. Okay, I know that I want to, and this is going to look terrible. This is oh, this is the wrong one. I'm in the wrong one here. Let's do that. And this is a special torch. Good. I'm glad you think so, Jeff. And this is flame and okay, flame, special torch, torch. And yep, there we go. This is what I'm looking for. Okay. And then I've got flashlight. Okay. So now if I go kick this thing off, every time I have this use of the method use, it will send stuff to the screen. So let's go and any big suggestions? Oh man, that is awesome because that I also have pulled up. If I can get to the screen, go check out Pro C# 10.NET 6 by my buddy Phil Japixi. And okay. Yep, you're going to suggest Phil? Yep. Oh, I'm glad you were. Okay. So it's going to, you know, and this is the reason I did this too, right? We're getting a new torch. And now I said it, but I did not prove it, did I? So let's do, that's what we're not going to do. And we'll do this right here. So after, and I'm making a point with this too. So I'm creating a new torch, but I'm going to set it and be able to use that later, right? If you, it's, you know, if we're really a scout out on an adventure, every time you need to use the flashlight, you're not going to go and buy a new flashlight. You're going to use the flashlight you have. But you know, think of it as I have this tool in my hand. What is that going to be? Well, a torch or a flashlight or a, you know, a flame could be right here. So, in fact, we can do, we'll just do that right there. And then use that, but I'm going to do a new flame. So we'll copy that guy there. There. And it makes reuse better. And so I never have coding problems. And if you believe that. All right, so as we step through, blah, 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 we're able to swap out the behavior at runtime. And now I've got torch, flashlight, back to torch. Now I got a flame, torch, now using torch, flashlight, now using flashlight, flame, now using flame. Now there's a special torch. And there we go. Strategy design pattern. So, all right. What else would be fun to explore, or are you guys ready to finish this up? And like I said, I think you should be able to do everything in this code in .NET framework, except this is what I would challenge. This guy having a base behavior. I don't know that that's in full framework. I know it is in C#8, but I think it's only a C#8 thing. But like I said, I think that is only on .NET Core, which is now just the name .NET, not framework, because naming is hard. All right. Any questions? Anything else you want to see? Anything we should explore? Dana, do you have any words of wisdom? Anything you want to share? If anybody has a question, you're welcome to come off of mute. All right.
Is Dana still here?
He probably is, but
I think he left. I don't see his name there.
Yeah, I was
okay.
looking through, I didn't see him either.
Okay, he did have to bail. Okay. All right. That's all right. All right, Scott. Any questions? Anything that you don't understand that you want to quickly cover?
Not right now.
Okay. This is kind of that, yeah, there's plenty for today. And a lot of this too is, and I'll make the code available if anybody wants it. That you step through it, go play, go figure why, does this work? Does this not work? Doing things like I did, creating like back over here in the do something method and go, what does this do? What do I see? What do I get to see here? And if I pass in a giraffe, what happens now? Right, is this kind of stuff. Go play. Go use tuples. Love them.
Tuples.
By the way, just to hijack this one, let's call this extra foo. And let's do, we'll do it right here. Foo returns a list of integer option 1 string name. That you can use tuples because a tuple is essentially a type. It's an anonymous type, but called a tuple. That you can use those as a generic or with generics. So like in lists. Generics would be a good discussion for another meeting. Cool.
I agree.
We can absolutely do this. How about return new list of that right there. I will quickly show that you can do this. And let's do 1 1 2 2, and now it'll return a new list of a tuple, list of tuples, and then these are the individual values that it will return. And you're thinking, oh, surely there's more. Absolutely. Blah. Yes, you can have generics inside generics. List string.
Yeah, but that makes it so fun to debug.
Yeah, I don't get what's the use case there? I know you could do it, but it just seems like I don't know.
Like
Spaghetti code.
I know one.
What's that?
I know of a use case.
Yeah, I would be worried about like that, that this is going to propagate, throughout
You're a
the
lazy developer and
the
you're trying to
app
be
and-
cute.
and
Somebody at
Um,
an organization where I used to work
Oh.
did that, and he overcomplicated something just so he could get away with making his unit tests a little easier he returned a list of tuples and was failed on the code review and threw a temper tantrum over it because the senior engineer said, "What are you doing?"
Yeah, because it's the same thing with the tuples. My deal is to abstract out the common code that you would use in both, but return a single value just so the unit test is a little more straightforward.
Yeah. Some of you guys here seem to have had a need for using tuples. I went to a meetup here in Oklahoma City. It was in the before times, before the pandemic. And the presenter said, "Yeah, everybody here uses tuples, right?" And every hand shot up except for mine. Yeah, everybody, yeah, these are great, aren't they? And I'm thinking, I never had a use case for them. I'm not saying they're bad, but I'm suspecting everybody just wants to be the cool kid on the block. And
No, I mean,
use
I use
I look
tuples.
at
I used
using
tuples in the
one
past
time-
too, and that's where like where when you get downstream, where the sort of ambiguity of the tuple sort of crops up, and it's like, well, wait a second, what is this? And I don't know. I haven't ever since then. I've been like, no, I don't want to use tuples. I want to like.
Yeah, and
I want to
Sean's
return
showing
one.
some great Sean's some great examples for how versatile they are, but it's like right there, you've got a list of integers with strings, and then embedded in it is a list of strings.
Yeah, and if it's that
Off the top of
complicated, it sounds like you have like an object model. I mean, if you
Yeah,
have like all
Exactly.
these things, like, do you have representation of something that should be an actual?
That's what I was gonna say.
Like,
I've thought about using them in the past, but then if I just take this object and I include this other list of objects as a property of that, and I just return it all, then that's all I have to return.
All right. So here's
oh,
a
man,
quick
that's
thing.
too.
What if do some biz logic here, and now I need to return the result, and it after some point they were like, hey, you're returning a value, but what we need to do is return the associated value along with it. Well, do I create this as a class type, or why not just do something like this? And now I have not a class type, but I have a simple type that's returning two pieces of data that are associated with each other, or however I want it to be. But you usually will start out with, I'm going to return one data piece, right? And then it's like, okay, it kind of morphs to, I need to not blow this thing too far up. And I certainly don't want to keep overriding, have all these overloads.
Sure.
I just want to be able to return more than one item at the same time.
It also
like-
boils down to not falling into the trap of too much syntactic sugar.
Yeah. Now I will argue, I will definitely argue this is already getting complicated and this is hard to follow. There will be time for this, but this right here is already more complicated, well, more complex than you will use on average. Now, that being said, what if this is information and you're doing some in-memory machine learning stuff, and this is chewing on data, and this is where your list with other lists can come in. You're not likely to send a list of int string, and another list to a database, although you could.
Well, that'll never happen because the administrator will never allocate enough memory to do that.
I think a big thing of this is who's writing the code. like whoever was talking about the meetup and they were the only one that didn't raise their hand, I would imagine that the vast majority of the people whose hands shot up worked in Python before. Yeah, where that's kind of where this syntax, like where tuples as we're using them now in C# came from.
I can see that. And that's also a complaint people are leveraging against Microsoft today is they're trying to be too much of catering to everybody.
Right. But like Sean was just saying, if you're working with machine learning, which Microsoft is trying to get C# to be that language, where Python is the language for that, they needed to bring this type of stuff in. I completely agree that if your first instinct is I'm going to return a tuple, you're wrong. That's I have a hammer, so now everything is a nail.
Bingo.
But there's absolutely use cases where, like when they first came out, I wasn't a huge fan of them, but I was talking to Sean at work. The client that I'm at, the thing that I'm doing right now is like taking objects and generically being able to flatten them into a flat file from any type. And some of the private methods that I wrote for that, I was thankful for the ability to use a tuple for those private return types, because creating a private class for that was just going to be stupid.
Right. That's the use case I think is best, is when you're doing private methods to do some operation and return a couple of pieces of data.
Right.
But if it's publicly exposed, I think that's a code smell.
I could probably do the same thing, because some of the stuff I've written recently, you pass in 2 parameters and you say, okay, I don't care which system this comes from. Everything else is going to figure out where that's coming from. It's going to figure out which query to run, which database it is, all that good stuff. But I'm going to return this one object that has all this information, regardless of where it came from. And
because later on, you're going to add more than the 2 things. And now you don't use tuples, you got to rewrite everything.
Yeah, exactly.
So what I'm doing, I'm using inheritance. And so I've got, 4 different classes that inherit from a base parent, and they each return, different things. But in the end, it all returns these same chunks of data, regardless of where it came from.
Just reminded me of something.
I mean, for me, I'm always having to I'm always having to turn into JSON or do mappings. So that's why, tuples for me just would be oh man, that's just to me, that would be worried that would creep up, and it's gonna you've got technical debt that's in there that you got to worry about. I can't do it with this one.
Mapping on this stuff too, but not a lot.
I think
for the most part, it's just
on
mapping the return object to a view model.
Yeah, I think it just falls back on, with great power comes great responsibility.
Mm-hmm.
There is that. Okay. Andrew, you made me think of something, so I'm going to do this really, really quick. You said you use inheritance, which it has its place. Now, notice that I have a scout with a flashlight, and then I have a scout with flame, and I have these classes that are very specific, where instead of, in fact, let's do this. It's going to have, screw it. I'm not going to mess with it. We don't have time. Imagine that I've got this class and he's got a flashlight, but this guy has a new flame, with flame versus another one with a torch. And I want to use this scout at various places, but instead of using inheritance to change and morph the type of class object that I have, instead of doing that, it's better
to do composition.
To do composition. In fact, let me do that. I'm going to take this.
You could do scout, comma, and then light source.
Right, exactly. So now, instead of we do this, I have this guy that holds types of data. And now my scout, I don't have a scout with a flame. I don't have a scout with a flashlight. I don't have a scout with a torch. Instead, I now have a using that composition ability to swap that light source. This is preferring, and this is you'll hear this on occasion, is that prefer composition over inheritance.
That's right. That's how you get the lasers on the sharks.
The squirrels with the lightsabers.
Exactly.
That's what I live with.
So when you have a class and you're able to provide things like this as a property, then you are able to swap that in and out and do it that way. What if I have a constructor, and I'm also fighting my slow computer, sorry. And I am going to say light source equals new, flame, because it's right there. Okay. And tell you what, we're going to do this even more. We're going to go light source like that. And I'm going to do light source like this. I want to touch on one other piece on this. Now, the constructor, before I can create a real instance of this scout, in the constructor is a defined dependency where this just says, hey, I can carry a light source. This one is saying you better provide one.
Right.
So anything that is a parameter of a constructor is a dependency. Even if it's a value type, even if it's an integer, it says, fine, okay, well, I have to have something in order for me to finish being treated as an instance. So now when I go to Scout up here and I get my red squigglies, it says I need to create something. So this guy starts out with, oh, null. That's valid because the type itself can be null. Now, or I could say, well, you got to do a new flashlight. Now, what really sucks about this is, one, it is a dependency. That part's fine. The problem is that when I want to create a new object here, I have to have a new instance of another class for this dependency. And this is I'm just teasing on a different discussion that we might have, I don't know, a couple months from now, whatever, because I'd love to talk about generics. But instead of saying new this, and to fulfill the reasons of having, fulfilling those dependencies of a constructor like this, I would rather use a library that keeps track of things like that and says, called dependency injection, or what's called
that's a
version of.
That's
I know
go away.
it is. I know, but it's still here. It's still here because C# still here. But with dependency injection is saying that I can create a new instance of this someplace and inject that through to either the constructor or some other means. And there's other ways of doing dependency injection. But using a library like an inversion of control container, then I can register this flashlight and just say, okay, well, when it's needed, when I need to create a light source, create a new, whatever I define it to be, flashlight and inject that in. Maybe this is a logger. Maybe it's a telemetry capturing code, whatever. When you register it in the library and then you come to use it, it will resolve a new instance to fulfill the constructor dependencies like that. So that's like dependency injection at an extremely high level. That's also a basis for another great 3-hour talk.
Yes, it is. My brain still thinks of dependency injection as just being
See you,
not
Dan.
because it's reworking my brain on what we're doing is actually called. because you redefine what it's called, and my brain's says, no,
All
know what
right.
it is.
Let's do, this is going to be my DI library. And shit, let's go make one off the top of my head. All right. So I have a DI library. One of the things that I need inside is, let's see, how far do I really want to go with this? Private dictionary of, yes, I want to do that. Now let's do T and K.
See you, Gary.
Yep. See ya. Thank you guys.
Yeah.
T and K, and I really should do this even after stopping the recording. I might just edit this part out because I'm thinking about how do I really want to do this, and this will be. No, I'll tell you what, I don't want to go that far into generics. Let's do. Oh no, I'm going to have to. Okay, string and then T. Okay, and this is going to be my. I'll just call it library.
No, not going inside.
Okay. And nope, I can't do that. I need to find where T is. Is an object. Ta-da. Okay. Public void register T, and I take in a string of name, and then I want do that. No, I don't want to do that. I'm going to do, yeah, we'll do that. Okay, and I'll say where T, it is a class, and I have to be able to create a new instance of it. Okay, but I also need this. Where T is that? Why are you giving? Oh, because it's that goodness there. DI type. Okay. And then I'll have another one that is public T resolve string name. We'll do something like that. All right. For lack of time, I'm not going to do like this whole thing, but think of it this way. I'm going to register. So let's say if I have a var L DI library. Oh, good Lord, I can't spell. Whatever equals
Live
new DI, right? It's like, I don't mind live coding. I just can't type for squat. Okay. Library dot register, and this is going to be flashlight right there, and then I'll say new flashlight. Give me time and I probably could. Okay, all right, so what I'm saying here is in this dictionary of library.add, this is going to be name and it's going to be DI type. Okay, now I'm going to return. I need to define it, don't I? No, let's do, now I'm going to do object and that, and I'm going to say library, yeah, right there, slash name, or not slash name, like that. Now, notice that I'm cheating quite a bit. So this is definitely far-fetched. Okay. So what I can do here is say var light equals di library dot resolve, and I want the flashlight. Now, magic strings, I know, are terrible. Now, this is going to break because this is an object, not a light source. So if I did this, and I also did, and I'm going to put my constraint on there, right there. And this is going to, no, you're not going to be an object. You'll be a type T, because I want you constrained even more. And check this out as T. Can I do that? It's not null here. Possible null reference. Yeah, that's fine. Okay. Resolve. Yeah. Okay. So this is like a dependency injection. I'm sorry. It's an inversion of control container that is extremely off the cuff. Okay, so you're going to do something of a register. You're basically, there's a store that is holding the registrations based on types. So I could have where T and TK is going to be like, when I need an instance of an object that it fulfills an interface, all right, call this one. You know, create me this one, and you're storing that in some sort of a library of such. And then when you go to resolve it, it is when it's going to say, okay, well, now you need that to be fulfilled. All right, well, it's going to do something like a resolve. And it obviously is going to be way different syntax, but this is really meant to get you that on the fly. So the registration is done at something like this. So now I can do di library underscore di library, and let's do that. And then I could say underscore di library equals new. Do that. That takes that away. Don't need it. And then I'm going to register this. Like that. There. So it kind of removes it from the exact same method. Registration and the storage, that data store here is going to be elsewhere, and the using thereof is going to be here. So technically speaking, you would not do that as a new there, but I know it's calling for an object type here. DI type. I'm going to add, I won't even create a new instance of it. I'm storing the type. And then I say, well, what type should this be? See, I really don't think I need that. I don't know. I could really think this out even further, but I'm way out of time. I can do return new T. Does that blow your mind? You can take and say, oh, well, I want this piece. It's going to come and get that. I need the object from, so var foo, get it from the data store, library name. Okay, so we have that, but I need a new type. So you can do foo dot that. Oh, that's why. Foo dot di type. Oh no, that's it itself.
I mean, you're passing your T in.
I know.
As long
But
as
you
it
don't-
maps.
You don't
You're good.
you don't need T on the resolve. I'm gonna get rid of it. It's oh gosh, who has activator? Yeah. Activator dot create instance. Is it from create instance from no create an instance of foo.
This is a generic one you should be able to do.
Yeah, but I was trying to try to stay where I don't have to specify the type on the resolve when I'm using a name as my object declarator there. So
If you get the name from the type from the dictionary, then you can pass the type into the activator, and that would probably do it. Because you're registering the actual type by the name.
right. No,
Yeah.
yes, I got type and name. So find the type based on the name out of here. So I have the type
Yeah.
to create an
Yeah.
instance of that type. Oh, why is that object cannot be? Oh, see. No, okay, yeah, that's right. I'm
Type.
storing a type.
Yeah, there you go. Yeah.
Now you do the create instance of type. No, not the generic one.
Oh,
There's a create-
is it?
Yeah, back up a little bit to. Is it like create from type or something?
Well,
Create
there's
instance
from, yeah, but it's taken the assembly file. Now there's an overload on that. Let me see if there's. What's our overload? That's assembly file, assembly file, assembly file. I don't want to do that. But okay, what if there's another activator type? Go away, go away, go away.
Is there just activator dot create instance?
There
Takes the type
is.
without the, and then you can have it of the type.
Right. Well, foo is that type.
Right, you had it as object before.
Yeah, I changed it to type.
Yeah.
So it's storing it as a type. And you cannot convert object to type T. Oh, because I don't know what foo is.
Oh, return is the problem. Okay. Yeah.
Yeah, it's trying to convert the object to a T. And that works.
Hmm.
Yeah, the
But
casting works.
then you would have to specify what type it is down
I
on
know.
26. Yeah.
Yeah, I know. And then I got to do it twice, and I don't want to do that. That means the register here. Actually, do I need? No, I'm not using T here. So take that off. Takes the register there. That's good. But the resolve is what I don't like. But anyway, we are, and I love geeking out on this stuff. This is like really fun.
It's so close. It's actually good seeing it this way, because whenever you talk about DI, you don't see the actual what goes on with the framework. So
right, because it does not store an instance. It stores the type information, because a dependency can also have its own dependencies that also have to be registered. So that also means that if, and it will too, when you go to resolve, it says, okay, well, what dependencies does the type you're looking for? What are those dependencies? And it will chase them. So one of the requirements is that when you have you can have a class that has dependencies in those constructor parameters, but the chain must end someplace where it is a parameterless constructor. Meaning you cannot just keep having constructor with dependencies, constructors with dependencies. At some point, it has to be, one, they all got to be registered, and two, they got to be, it has to end at a constructorless parameter. Parameterless constructor. I think I just entirely said that wrong a second ago. Strike that, reverse that, as my other friend Andrew would say. He would also say great minds think alike, and so do ours.
Mhm.
All right, so there is a really quick dependency injection, and I'm not saying it works. I'm not even going to try it, but you kind of get where it's going.
Yeah, I think I might have solved that in the serialization stuff I was doing, but I would have to double check because like these were the type of things I was trying to figure out, and I'm pretty sure I got part of it, but I might have needed to specify the type.
Okay.
I think if it registered the type, not just a string, that might make this closer.
Well, I mean, I'm giving the, and I could do it as a list. I don't have to do it as with a string, but I don't want, I want a single key. I don't, because you can have multiple instances of that type registered. Now, a good DI library is not going to allow that. But here I'm just saying, I'll give it a key so that I don't have more than one. And obviously in the register, I would have to say, well, check to make sure that, well, in fact, by the fact that it's a dictionary, you cannot add the same key, but I would do a search to make sure, oh, you don't already have this by a different key, that same type.
Isn't in the DI, it's not going by a string, it's going by the interface. So it's like when you ask for this interface, what type you actually get.
Yeah, that's
Right.
usually what it could be
And
like
so
the same type. You could just usually, yeah, you can actually give it the same type for registering, or you can do an interface. Usually it's an interface. When you ask for it, you request the interface back.
Right.
I do need to go.
Sometimes-
I've got to
yeah.
run the
Like
raccoon off, the one that was ringing my doorbell at 4 a.m. this morning and making it go off in the house. And so I've been up since 4 a.m. this morning because of this damn raccoon is going to eat cat food, and I'm going to try and get it this time.
I am
It's
so
on the-
leaving that in the recording.
It is on the carport right now eating cat food, even though the dogs are barking at it. So I'm going to try and get the door open and get a shot at it before it makes it out of here. Thank you,
See
Sean.
ya.
Why do you
Great,
leave
buddy.
why do you leave cat food out for the raccoons?
I don't.
yeah, he leaves raccoon food out for the raccoons, but they
Yeah.
just eat cat food
Apparently, I'm
instead.
feeding the raccoon, the possum, and a stray cat, along with my cats. But thanks, Sean. Y'all have a good night. I'm
See
going
ya.
to try and make sure this raccoon never wakes me up again by ringing my doorbell. I do have it on video too. You see
See it.
the fuzz of the raccoon going by. Later.
See ya. Okay, if I did that and then I said library equals, I'm not gonna do it there. There. Okay. Anyway, I'm out of time. I mean, we could geek out on this for another 2 or 3 hours and replace an inject or something, but anyway, okay. All right. So real quick, has this been worth your time? And I'll keep saying my disclaimer. This is completely meant to be ad hoc, and I wasn't even planning on recording. I still don't know if I'm going to publish this. But I really hope that the ad hoc adventure was worth your time and you learned something.
I mean, these questions come up a lot, and it was very helpful going through this.
Good deal. Yeah, and like I said, I don't know if you were here for it, but I was talking with a friend of mine about things like inheritance, to what happens when you pass in an object to a method, what really happens with it, how is it treated versus is it copied, all that jazz. And I thought that, you know, if he's got this question, I know others have this question. So this is why I wanted to dig in on it. And, you know, so anyway, I hope it was worth your time.
Yeah.
Fine.
Cool deal. All right.
You know, sometimes we learn things by doing and we miss the little holes. And you got to go back and pick some of this up.
Well, even as long as I've been doing C#, there's still little gaps in my knowledge too. So my job here tonight is simply to, you know, if somebody else has a gap, well, let's go explore it. You know, there's stuff that I learned tonight too. So, you know, I'm not perfect, so I'll get out here and be vulnerable and just plug away. Let's go. So I had fun too.
It changes. That's the other thing. It's just like, and even though you've been in a long time, it's like constantly changing.
There are some syntaxes that are coming about that are amazing. And you're like, I can see myself using that. But again, because I'm a cloud architect, I just don't code every day. I really have to put my hands to it and go play as much as I can. The problem is I don't get to do that until at least February, because I now need to get 3 Microsoft certifications before February 10th. So
You talking
yeah.
about in a month and a half?
Yeah.
Holy smokes.
Yep. So, and you know, I can do it. It's just going to be spending a lot of time studying. And so I've been wanting to I love doing these kinds of things, these kind of talks where we just go and explore. I love it. I don't have to have every little detail predefined and stuff. You know, it's like with the Safari thing. I knew where I wanted to go. I knew kind of what I wanted to talk about. Strategy design, the strategy design pattern and why you want to favor composition over inheritance. And it's like, I knew where I wanted to take you, but things like light source, in my first example, when I did this, it was a weapon. It's like you had a knife, a sword, and a gun, and you know, same thing. You when you try to use it, it's going to have different functionality. And it's like, I don't even know why. Just tonight, I came up with, hey, let's make a light source, and it was just, all right, I'll run with it. So
It's funny.
Shipping's always good.
So,
I
Sorry,
said shipping methods are always good.
yeah, shipping methods are always great. Hard to work with a lot of developers with pedantic tendencies that you may not be aware of. Yeah, I totally agree with that. Shipping methods are great. In fact, I've taught multiple people about the strategy design pattern with that example is the shipping methods. How UPS ships is similar, but different enough than FedEx, than DHL and whomever else. And so yeah, that I can use that easily as a great example for strategy design pattern.
just thought it was brought up that when that example came up with the gun, it was like showing the IntelliCode now how that analyzes your code and how like you were doing something before, and it brought up something that you had done before that would look kind of like what you're doing now, but was not really part of
that.
Not fit.
That would actually explain why gun came up as a suggestion, because I did do an adventure class. I did have a scout, and I did not create a weapon. But yeah, you're right, because when I did one of these, hey, let's create a new light source object, and he goes, gun. Wait a minute. It had to have learned it from the last time that I was doing very similar to this.
Sometimes it's very helpful, but sometimes it throws at stuff that's just not at all what you're trying to do, and you're like, wait a minute.
Exactly. Okay. If you guys want, hang out for a second, and I will go ahead and stop the recording, and we will go from there. So before I stop it, thank you guys for coming out. I hope you guys enjoyed this. And remember, our next meeting is January 12th. So with that, I will stop the recording.
All right.